Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Example 53 on equilibrium of a particle. Two rollers of weights P and Q are connected by a flexible string DE and rest on two mutually perpendicular planes AB as shown below. Find the tension S in the ring and the angle theta that it makes with the horizontal when the system is in equilibrium. The following numerical data are given. P 300 newtons, Q 500 newtons, alpha 30 degrees. Assume that the ring is inextensible and passes freely through slots in the smooth inclined planes AB and BC. So here is the given figure. So take note that the surfaces in contact with the rollers are frictionless and alpha is 30 degrees. This angle is 90 degrees. Therefore, the angle of inclination of AB is 60 degrees. In this problem, I'll present two solutions. One is the longer one by using the free body diagram if it's ruler, and the second one is using the first triangle, and the second one is a bit shorter for this case. But let's have the free body diagram principle or approach first. So for roller E, so we have the weight which is 500 newtons because Q is 500. Then we have the tension in the string DE, and let's have the tangential and normal axis. This angle is equal to alpha, and alpha is 30 degrees. And tension S, then S makes an angle of theta with horizontal. So this is the normal reaction at the point of contact between the ruler E and this surface BC. So summation forces horizontal equals 0. Then NE sine of 30 degrees minus S cosine of theta equals 0. So that means NE is equal to S cosine of theta. Then summation forces vertical, NE cosine of 30 minus S sine of theta, vertical component of S, vertical and horizontal only, don't mind the tangential and normal axis. Minus weight 500 equals 0. So we have NE, which is 2S cosine theta times quantity cosine 30 degrees minus S sine theta minus 500 equals 0. Simplifying, square root of 3 times S cosine theta minus S sine theta minus 500 equals 0. Call this equation 1. Then let's have the free body diagram of the second ruler. Remember, this angle of inclination is 60 degrees, 90 minus alpha, or 90 degrees minus 30 degrees. So this is the weight, 300 newtons. Then we have the tension in the string and normal, which makes an angle of 60 degrees with the vertical. So normal summation forces along X first. So we have S cosine theta minus ND sine of 60 degrees, the horizontal component of ND equals 0. So that means S cosine theta equals square root of 3 over 2 of ND. Then summation forces vertical, S sine theta minus ND cosine 60 degrees minus 300 or equals 300. So S sine theta plus ND, which is from this equation, ND is 2S cosine theta over square root of 3 from this equation. Substitute here. Then cosine 60 is 1/2 equals 300. Simplifying S sine theta, it is equal to 300 minus S cosine theta over square root of 3. Let's substitute this into equation 1 here. So square root of 3 times S cosine theta minus S sine theta, which is equal to this, minus quantity 300 minus S cosine theta over square root of 3 minus 500 equals 0. So from here we can solve S cosine theta. which is a constant. So S cosine theta equals, using your calculator there, 500 plus 300, so 800 divided by quantity square root of 3 plus 1 over square root of 3. So you'll get S cosine theta 346.41. Call that equation A. Then from S sine theta equals 300 minus S cosine theta, which is 346.41 over square root of 3. So S sine theta is equal to 100. Equation B. So divide S sine theta equals 100 with equation A, which is S cosine theta equals 346.41. We can cancel S. So tangent theta, which is sine theta over cosine theta, equals 100 over 346.41. So tangent theta is 100 over 346.41. From there, we can solve theta, which is equal to 16.10 degree. Then to solve for S into this equation, S cosine of 16.1 degrees equals 346.41. So S is equal to 360.6 newtons. Now for the other solution, it is on the next slide. So here is the better and shorter solution by the force triangle after this free body diagram. So the total downward force is 300 plus 800 is 300 plus 500 is 800. Then we have the normal at D, which makes 60 degrees with the vertical. And then we have S, sorry, NE rather, because S is internal. We do not touch S, by the way. So that's NE, then this is 30 degrees, the angle that NE makes with the vertical, and therefore this is 90 degrees. So from here we can solve ND and NE. ND is 800 sine of 30, while NE is 800 cosine of 30. So ND is 800 sine of 30 degrees, so it is 400 newtons, while NE is 800 cosine of 30, was 692.8 newtons. So having found ND, we can now solve for S by summing up forces horizontal. So S cosine theta minus ND, which is 400, then its horizontal component is 400 sine of 60 equals 0. So S cosine theta is equal to 346.41, equation A. Remember that this is the same equation in the preceding slide. Then here, summation forces vertical, S sine theta plus ND cosine 60, 400 cosine 60, minus 300 or equals 300. So solving for S sine theta equals 100. So therefore that's equation B, which is the same equation as before. So S sine theta divided by S cosine theta is tangent theta, and it is equal to 100 over 346.41. So from there we get the same answer, theta 16.10 degrees and S is 360.6 newtons, because this is the same calculation as before. Now for your part, a weight Q is suspended from a small ring C supported by two cords AC and BC as shown below. The cord AC is fastened at A while the cord BC passes over a frictionless pulley at B and carries the weight P. If P equals Q and alpha is 50 degrees, find the value of the angle beta. So you have to show that the angle beta is equal to 80 degrees. So I hope that you can solve this problem. Just draw free body diagram and set up equations of statics. Here is problem 54 on equilibrium of a particle. This is the second example. The 100 kilogram box D is suspended from the ceiling by three cables whose ends A, B, and C form an equilateral triangle in the horizontal plane. So determine the tension in each cable. So take note that in this plan, this is the suspended 100 kilogram box, and since this is an equilateral triangle, we expect that the tension in this cable would be the same. But let's just show that they are equal. We will not conclude yet, although the tension in each cable is really expected equal. So the distance from A perpendicular to BC, so let's have the solution first, is 2 meters, 2 meters cosine of 30. So 2 meters cosine of 30 is this height here, which is equal to this. So that's square root of 3 meters. So since this is the centroid of the triangle, this is 2/3 of square root of 3. So this is the weight free body diagram. Then we have S BD, S CD equal. Then this is tension in AD. Tension in AD. So this is 2 square root of 3 over 3, 2/3 of this value. So this is 1/3 of this value, square root of 3 over 3, or 1/3 of square root of 3 meters. Then this is tension in AD. So take note that there are two cables here, this cable and that cable, and they are equal. So summation forces horizontal first. SAD times this distance, which is 2 square root of 3 over 3, divided by distance. There's no movement along this direction, so it is just square root of 2 square root of 3 over 3 square plus vertical distance 2 square of AD. So SAD times 2 square root of 3 over 3 over distance quantity 2 square root of 3 over 3 square plus 2 square. So this distance is this horizontal distance here, which is this, and vertical distance 2 meters, 2 and 2 square root of 3 over 3. That's why it is just 2D AD. There's no movement along this direction. Then this is equal to, there are two cables, they are equal, so times 2. This component of distance is square root of 3 over 3, so 2 times SBD times square root of 3 over 3 over distance, square root of 3 over 3 square plus 2 square, which is this, plus 1 square. Movement along this direction, so this is half of 2, which is 1. Again, this distance is square root of 3 over 3. Then vertical distance, which is this, 2. And distance, component of distance in that direction is half of 2, 1. So simplifying this, cancel out square root of 3 over 3, cancel out 2. Then same distance. So SAD equals SBD. That's the conclusion. Therefore, the three cables are of equal tension. So the last equation is summation forces vertical. The vertical component is 2 and the distances are already set up. So 3 times, because there are 3 cables and each is shown to be the same. So it's 3 times SAD, the vertical component distance 2. This is the distance, just copy it. Then equals 100 times 9.81. So solving for the tension in SAD, which is equal to the tension in BD, tension in CD. So SAD equals S, BC equals S, SBD equals SCD. It is equal to 377.6 newtons. Now for your part, a 15 kilonewton automobile is suspended on a lightweight platform by 4 cables of equal length. Each cable carries the same tension because of symmetry. So determine this tension. So this is the figure in pictorial view. So take note that the tension in this cable is the same as expected because they are attached in a symmetrical manner. So determine the tension in this cable. So show that it is equal to 6.155 kilonewtons. So this is the first problem on equilibrium of a particle in 3D. A 15 kilonewton horizontal force is applied to ring A where three cables are attached. Determine the tension in each cable. So here is the given figure. So let's have S, the tension in this cable as SAB, SAC, and SAD. So for the length of AB, it is going to the left, then down. So distance AB is square root of 1.2 square plus 0.4 square. Then 0 along X or along Z. So let's call this the X-axis, the Y-axis, X, Y vertical, then Z, this axis here going forward. So distance AB is equal to 1.2649. Then distance AC, it is to the left 1.2, up 0.4, then forward 0.3. So distance AC is square root of 1.2 square plus 0.4 square plus 0.3 square. So distance AC is equal to 1.3 meters. Then distance AD is going to the left 1.2, upward 0.3, backward 0.4. So distance AD is square root of 1.2 square plus 0.3 square plus 0.4 square. So it is also 1.3. So first equation, summation versus x. Remember that we imagine this is the x-axis going in that direction as positive, or going to the right as positive. So 15 equals SAB times 1.2 over distance plus SAC times 1.2 over distance AC plus SAD times quantity 1.2 over distance of AD, which is 1.3. Call that equation 3. Then summation versus vertical equals 0. AB is negative. So we have SAB times negative 0.4 over distance 1.2649. Then plus SAC, vertical distance component is 0.4 over distance 1.3 plus SAD times 0.3 over 1.3. Vertical component of SAD component of distance is 0.3 over distance 1.3 equals 0. And the last equation would be summation forces along this axis. This is the positive direction. So SAB 0 over distance 1.2649 plus SAC times 0.3 over distance 1.3, then minus or plus SAD times negative 0.4, distance is 0.4, going backward, over 1.3 equals 0. Solving these three equations simultaneously, then we have SAB equals 7.458 kilonewtons, SAC equals 4.906 kilonewtons, and SAD equals 3.679 kilonewtons. Now for your part, here is your problem. A 15 kilonewton horizontal force is applied to ring A where three cables are attached. Determine the tension in this cable. So it's somewhat similar, but this time this is 1 meter, and take note that we have cable tensions that are the same vertical distance. Then this is the same 15 kilonewtons, and show that these are the answers. So SAB is 8.078 kilonewtons, SAC equals SAD equals 4.308 kilonewtons. So that's it for your part.